Alright, so we are going to talk about writing equations from graphs for piecewise functions. Okay, so if you notice here, you can tell that the graph changes at 0. So it's going, one function's this way, one's there, so we're going to have two functions here. If you look at here, here's one function here, so that's going to be 2. This one has 3. Okay, so let's start with this one, and let's talk about writing the equations first. So our y-intercept, remember we have y equals mx plus b. So our y-intercepts for both lines going to be 0. So we just basically have to find the slope. We normally do the one on the left first and then the right when we write the final function. So here, the slope is 1. Down 1, down 1, down 1. So slope is 1. So that function would be y equals x, and then there is 0. Okay, so let's not worry about anything right now but the line. Let's don't worry about our limitations and things. Okay, here, if we were to find the slope on this one, you go up 2 over 1, up 2 over 1. So the slope for that is going to be 2, and so that's going to be 2x. Again, the y-intercept 0, 0. Okay, so these are our two equations. Okay, so what we're going to do now is we're going to say, we can do f of x, we can do g of x, we can do y equals, so whatever you want to here, equals, and then we're going to draw the little brackets. So we're going to put this first one in here, and then the second one. Again, it's normally left to right, and then we're going to have to go up here and determine where the starting. So this starts at 0, and it's going to be less than 0, or you could put equal to there. And then here, 0 is going greater than. One of them has to be equal to because there's no open circle. Okay? They could both be. Normally, though, it's one or the other. So you can pick there, and you could be right either one. Okay? All right. So let's look at this one. This one, we do have an open circle, and we have a closed. So we don't have to pick here or go. Again, we normally start with the graph from the left. So let's look at this. So we're going to have y equals, let's look at our slope. So it looks like it's going to go down to here and over. So that's 1, 2, 3, and then over 2. So our slope here would be 3 halves, and it's positive because the line's slanting to the right. Now, my b is not going to be 0 here. And I go 1, 2, 3, up and then over 2, I don't know where the y is. So I'm going to need to use a point to find my y-intercept, okay? So we know that y equals 3 halves x plus b. So we can use this point right here, 1, 2, 3, negative 3, 0. So I'm going to use the point negative 3, 0 to write my function. So I'm going to plug in what I know. And then I'm going to solve for my b. So I have 0 equals negative 9 halves plus b. I add 9 halves to both sides. And I get 9 halves equals b. So that first function is going to be 3 halves x plus 9 halves. Okay? Again, I'm not going to worry about my domain restrictions yet. I just want to write my function. So that's going to be the first one here. Okay, if I'm looking at this next one, oh, that one's quite easy, right? We're at negative 1 and y equals negative 1. So my other one is y equals negative 1. Okay. Anyone have a question there? All right, so now we're going to go down here. And we're going to take this equations and we're going to write our piecewise function. So 3 halves x plus 9 halves. That's the graph on the left. And then y equals negative 1. Now let's go up and let's look at our domain restriction. Where does this graph start? Right here, and it goes off to the left, right? So we're going to need to say, what's this? Negative 1. When x is negative 1, it's less than negative 1, but not equal to because of the open circle. So x is less than -1. Okay, then here at -1, it's closed circle, so that's going to be greater than or equal to, and then again when x is -1. So x is greater than or equal to, because of the closed circle, -1. Okay, let's go back up here now and let's look at this one. Okay, so what's the slope on this one? Well, we go down and over, down and over. So the slope's going to be 1. So that's going to be y equals x. Now here, if I go up and over, I know that my y-intercept is going to be +2. So I don't need to do this by plugging it in, because I can tell by the graph by going up and over using my slope. So that's going to be my first one. Okay. Then we're going to look at the second one here. What is the slope there? Again, it's +1. And then my y-intercept, 1, 2, 3. So that's going to be +3. Okay. So now let's look at this last one. Oh, look, they're so nice to us. They just keep giving us 1 as the slope. And so this way, now I can go backwards. And so my y-intercept is going to be +1. Okay, so these are my 3 functions going left to right, and now I'm going to write them in my piecewise function. So I'm going to have x + 2, x + 3, and x + 1. So if I look at this first one, where does the x start on this first one? It starts at -1, and it's closed circle, so, and it's going to the left, so it's x is less than or equal to -1. Okay, if I look at this next line, it goes between -1 and 1, but they're both open, so it's between -1 and 1, and they're both open, so you're going to do it that way. Okay, now the last one starts at 1 and goes to the right, so that's greater than and equal to, because it is closed. Now these are going to take some practice and some thought. You just need to remember, go left to right and take them one step at a time. Okay, so let's look at this first one here together. You can tell there are 2 pieces here. The y-intercept 0. So we're going to write the equation of the pieces. So first we're going to do this first one. So y is going to equal the slope there, down and over, down and over. So the slope is 1, so that's y equals x. Okay? So we have y equals x, because it goes down and over, down and over, down and over, down and over. All right, then this next one, we're going to go 1, 2, and over 1. So that's going to be y equals 2x. Okay? So they're both a positive slope. This slope is just greater than this one because it's 2. The y-intercept is 0. Okay, so now if we look at the domain for this one, it starts at 0 and goes less than 0. And then this one, 0 greater than 0. One of them, it does not matter which one in this case, has to be equal to. So I'm just going to put that one. You can put this one. Okay, so then you have y equals x and 2x. So x is less than 0 is the domain restriction, and x is greater than or equal to 0. Okay, let's look at one more together. This one's a little hard to read, so we're going to do our best we can. Sorry about this, guy. So first of all, we're going left to right, so we're going to start at this one. And so it's going, looks like it's going to go down 2 and over 1. So down 2, left 1. So that's going to be y equals 2x. Now the y-intercept, 1, 2 over 1, is going to be at 3. See, we can go 1, 2 over 1, 1, 2 over 1. So that's 1, 2, 3. So the y-intercept's at 3. Okay. So if we're, let's just go ahead and do our domain. We're right here. So that's going to be at -1. It's open circle at -1, and it's going less than -1. All right, this next one is y equals 1. It's between -1 and 1, open and closed. So -1 to 1, open, closed. So x is in between -1 and 1. All right, so here, the slope here, if you notice, it's going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay? So y equals x. So if I go down and over 0, so the y-intercept 0. It starts at 1, and it's equal to, so that's going to be that. Okay, so let's write our piecewise function. So we're going to have 2x plus 3. X is less than -1. Y equals 1. And x is between -1 and 1. And then y equals x. And x is greater than or equal to 1. Okay, so I want you to do these two. And then we will check our answers in class. And then work on the back of the worksheet. And I've uploaded the answer key to your plan book for that. And then check plan book for your assignment. And guys, I understand this is going to be tedious. It's going to take time. But you're going to have to practice this. That's all I can tell you. It's something you need to do, so you're going to need to practice. All right. Reach out, please.